All right, we are going on a journey to the absolute most extreme and mysterious objects in the entire universe, black holes. So buckle up, because we're going to explore what's hiding at the very end of gravity's reach.
I mean, that sentence just perfectly captures it, right? A cosmic abyss, a one-way trip, a place that just bends the rules of reality as we know them. And you know, this is a concept that's been messing with scientists' heads for over a century.
And that is the ultimate question, isn't it? The one that's driving so much of modern physics. So in this explainer, we're going to try to break down what we think we know, and maybe even more excitingly, what we don't.
Okay, so before we can even try to tackle that huge question, we've got to get the basics down. You have to understand the basic structure of a black hole. Think of it like we're dissecting a cosmic beast. Let's start right at its heart.
So picture this. You take a giant star, sometimes billions of times heavier than our own sun, and you crush all of that mass down into a single point, a point with literally zero volume. Yeah, it's a spot with infinite density, where everything we know about physics, about space, about time, it all just stops working. Our science literally has no words for it.
So if the singularity is the heart, then the event horizon, that's the skin. Now this isn't some wall you could, bump into. It's more like a line in the sand, a theoretical boundary. And here's the kicker, it's the absolute point of no return. The second you cross that line, your fate is sealed. Your only destination, the singularity.
So the really important thing to get here is the difference between the two. The event horizon, that's the boundary defining the black hole. The singularity is the infinitely dense point inside it. Think of it this way. One is the edge of the cliff, and the other, that's the bottomless pit waiting below. Getting this difference is absolutely crucial for everything else we're about to talk about.
Okay, so now that we know the parts, let's talk about what happens when you get close. Because as you approach that boundary, the universe, it starts to get weird. Really weird. We're not just talking about strong gravity, we're talking about reality itself warping.
And this is not science fiction. You've probably heard of Einstein's idea that huge objects like stars literally bend the fabric of space-time, right? Well, a black hole takes that idea and cranks it up to 11. It's the most extreme example possible. So if you were falling in and I was watching from a safe distance, I would see your clock start to slow down until it looked like it stopped completely right at the edge. It's wild. Your reality would literally split from the rest of the universe.
And yeah, this journey inward, it's strictly a one-way street. First, you get close to the boundary. Then, you start to feel that insane gravity, the kind that would literally stretch you into a noodle. Then, you cross the event horizon, and poof, you're gone from our universe's point of view. And finally, there's that unavoidable final trip, straight to the singularity.
So we have a pretty decent picture of what happens, based on the physics we have today. But, and this is a big but, that picture is full of holes. And this is where things get really fun, because we're leaving the textbook behind and stepping into the wild world of speculation.
This is the question that keeps physicists up at night. I mean, is everything that falls in just gone forever, crushed out of existence? Or could there be something else going on inside? The possibilities here are just mind-bending.
The weird thing is, the math that describes black holes, it also points to some seriously bizarre possibilities. And these three ideas you're looking at right now, they're pretty much the bleeding edge of theoretical physics. Each one completely messes with how we think the universe is supposed to work.
Okay, let's start with the one you've probably seen in movies, wormholes, the idea of a shortcut through space-time. Now, this is pure theory, but the equations suggest that the way space-time gets twisted inside a black hole could potentially link up with another place, or maybe even a whole other universe.
For ages, the rule was nothing gets out. Simple. But then along came the legendary Stephen Hawking. He figured that because of all the weird quantum stuff happening right at the edge of the event horizon, black holes should actually be giving off a tiny bit of radiation, a faint glow. And what does that mean? It means they aren't totally black. And, get this, over insane amounts of time, they can actually evaporate. Just disappear.
But wait, Hawking's idea creates a huge headache for physicists, because there's this really fundamental rule in physics that says you can't destroy information. It can change form, but it can't just vanish. So, think about it. If a black hole sucks in a star, with all the information about what made it a star, and then that black hole just evaporates, where did all that information go? That is the information loss paradox, and it's one of the biggest unsolved puzzles in science today. It's basically a cage match between Einstein's theory of gravity and the rules of quantum mechanics.
So all of this is what brings us to today. And you got to understand, studying black holes isn't just about looking at weird stuff in space. It's about pushing the very boundaries of what we can know.
They're like the universe's ultimate stress test. They're the one place where the two biggest ideas in physics, Einstein's general relativity and quantum mechanics, are forced to collide. And figuring out the paradoxes they create, that could be the key to a brand new, unified theory of everything.
And we're making incredible progress. We've heard them collide thanks to gravitational waves. We've even taken a literal picture of one shadow, that event horizon. Our ability to peek into these mysteries is getting better every single day. So the journey into gravity's end? It's really just getting started. The secrets they hold could completely rewrite the story of our universe. What secrets of the universe will they reveal next?